Hello and welcome to this revision session for GCSE Separate Science Physics Paper 2, where we're going to focus on the topics which will come up on the 2022 examinations. So in this revision session we're going to look at how to answer examination questions on GCSE Physics Paper 2. So if we've been successful and we've learned in today's lesson, we'll be able to answer GCSE Physics examination style questions, assess your understanding on GCSE Physics and understand what topics you need to improve upon for GCSE Physics. So how should you carry out this revision session? Well, when completing your work in this revision session, divide your piece of paper into two sections. Place the section on the left hand side larger than the one on the right hand side, and in this section write down your working out and answers to the question in the revision session. Make sure when you're doing this you write out your answers in full sentences and you show your full working out, whilst on the right hand side write down any piece of information which you find useful or any hints and tips on answering questions from this revision session, and at the end of the revision session write up these notes into a revision sheet for you to use independently. So let's have a go at a few questions. Now again, all the questions are based on topics which will come up on the 2022 examination. So let's first look at the topic of forces. So the first question says, suggest two properties that should be the same for each spring assuming they're identical. So pause the video now, then unpause the video when you want to go through your answer. Right, it's important to know what probably should be the same for identical springs. So you should have that they have the same length, the same diameter and the same spring constant. And again, the spring constant is the force needed to extend that spring by 1 meter. The next question says, figure 6 shows a key and its spring. The key must be pressed with a minimum force of 0.80 newtons before the key touches the switch. Calculate the spring constant of the spring in figure 3. So pause the video now, then unpause the video when you want to go through your answer. Right, well, it's very important to know that what are you given in this question? You're given the force and you're also given the extension of the spring, or the compression in this case, but compression is just negative extension. So we can then look at our equation sheet and we say that force is equal to spring constant times by extension or compression. So we say it equals 0.80 equals k times by 0.040. We then rearrange it, make k the subject and work it through to be 200 newtons per meter. Now it's very important when you see this mark scheme, as this is how you should set out your work in a physics exam. You should write out the equation, then directly substitute the values from the question into the equation, so you can it shows the examiner you recognize what each quantity is in the question. You then rearrange it, you then write out your final answer. Our next question says, figure 8 shows a girl bowling a ball along a 10-pin bowling lane. The girl is trying to knock down the 10 pins at the end of the bowling lane. Velocity is a vector quantity, speed is a scalar quantity. Describe what is meant by a vector quantity and a scalar quantity. And then the bowling lane is horizontal, explain why the bowling ball decelerates as it travels down the lane. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important you know the definition of vectors and scalars. So a vector is something which has a magnitude and a direction, whilst a scalar has just a magnitude. Now the next question is, why is the bowling ball decelerating? Now you should be aware that acceleration and deceleration are caused by a resultant force. So the first thing to note is that a resultant force acts on the ball. Now because it's decelerating, this resultant force must be against the motion of the ball, and therefore it's a resistive force like friction or air resistance. Our next question says that figure 9 shows the bowling ball hitting one of the pins. Write down the equation that links mass, momentum and velocity, and the bowling ball has a velocity of 5 meters per second when it hits the pin. The momentum of the bowling ball is 26 kilograms per meters per second. Calculate the mass of the bowling ball. So pause the video now, then unpause the video when you want to go through your answer. Right, this first one isn't the type of question that will come up on the 22 exam papers, but you are given the equation in the equation sheet, which is momentum is equal to mass times by velocity. Now again, like we mentioned before, when we're doing a calculation, we should substitute our values directly from a question into the equation. So we can now say that 26 is equal to mass times by 5. The second step is always to rearrange it and to make mass the subject. So we say mass is equal to 26 over 5, and our final step is to write our answer in 5.2 kilograms. The next question says, explain why the bowling ball slows down when it hits the pin. Use your ideas about momentum in your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, what's very important in these types of questions is you make sure if it says to you use your ideas about momentum, you actually give your answers regarding momentum. Lots of people give answers in terms of forces or in terms of energy stores, but when it asks about momentum, you've got to talk about momentum. Now, what you should always remember in every collision is that momentum is conserved. So therefore, if the bowling ball is slowing down, okay, what does that tell us about the momentum of the bowling ball? Well, momentum is mass times by velocity. So its velocity is going down, its momentum is going down. So therefore, the momentum of the pin which it hits and makes it go to faster velocity is now increasing. But the total momentum before and the total momentum afterwards is the same. It's just transferring between the ball and the pin. The next question says, Figure 9 shows a child on a climbing wall. There's a crash mat at the bottom of the wall. The child jumps off the climbing wall and lands on the crash mat. The momentum of the child just before landing is 160 kilograms meters per second. Calculate the velocity of the child on landing, and the mass of the child is 50 kilograms, and give the unit. So pause the video now, then unpause the video when you want to go through your answer. Right, what's very important to note is you should be aware of, we're trying to work out velocity, we're being given a momentum and we've been given a mass. So we can say momentum is mass times by velocity. Again, substitute the values directly in. So 160 is equal to 50 times by v. We then make v the subject. We do 160 over 50 is 3.2. And then what's our unit for velocity? In science, it's always meters per second, which will get you your final mark. Now the next question says it takes 0.80 seconds for the child to stop after hitting the crash mat. Calculate the average force the child exerts on the crash mat during the landing, and then explain why the crash mat reduces the risk of injury if the child falls. So pause the video now, then unpause the video when you want to go through your answer. Now, you should be looking on your equation sheet, and your equation sheet tells you that force is equal to the change in momentum divided by time. Now, you were told the momentum before the child hit the mat was 160. Now, when the child hits the mat, its momentum goes to 0 because it's stopped moving, and momentum is mass times by velocity. So it's stopped moving, velocity 0, so momentum is 0. So the change is 160. You then divide it by the time, which is 0.80 seconds, and we get our answer to be 200 newtons. Now the next question asks us about why the crash mat reduces the risk of injury as it falls. Now you've got to talk about this in the terms of force is equal to change in momentum over time. So there is scope for talking about the real world applications of this, but always related back to the equation force is equal to change in momentum over time. So we would say that firstly the crash mat does compress, but the reason why it's this important is because as the crash mat compresses, the time taken increases, and therefore the rate of change of momentum, how quickly the momentum changes, is slowed. So whilst the change in momentum is the same, the time it takes to change this momentum goes up, so the rate of change goes down. So from our equation, force is equal to change in momentum over time, therefore the force is lower, so there's less chance of injury. In our next question, it says a student ran a 100 meters race, and figure 11 shows the distance time graph for the student. The student reaches a constant speed at 4.4 seconds. Determine the constant speed of the student at 4.4 seconds. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important to know that you should be aware that the gradient of a distance time graph is going to be the speed. So what you need to do if it says to use this graph is to therefore work out the gradient of the line. So what you're going to have to do is draw your gradient triangle and make sure you actually draw the triangle on the graph. You can then work out the gradient by doing the change in y over the change in x, and you get your answer to be about 9.5 meters per second. Now, as the speed of the student increased, the air resistance acting on the student also increased. Explain why the student reached a constant speed and use ideas about forces in your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important that when you do this type of questions, you actually talk about the forces. So you've got the thrust force or the forward force, and you've got the air resistance acting against motion. And you should always know that air resistance always acts against motion. So the first mark is saying air resistance acts in the opposite direction to the forward force. Now the air resistance will always increase until it actually equals the forward force. And at that point, the resultant force equals 0 because the forward force and backwards force equal each other. So therefore our resultant force is 0, so our acceleration will be 0. The next question says another student in the race decelerates from a maximum speed of 9.6 meters per second to stop at a distance of 25 meters. The mass of the student is 75 kilograms and calculate the average resultant force on the student given your answer to two significant figures. So pause the video now, then unpause the video when you want to go through your answer. Right, now this is a 6-mark question, so there's going to be multiple equations being used here. Now the first thing to note is we can work out the kinetic energy of the person because we've got a maximum speed. So we know that the kinetic energy is a half times by the mass, which is 75, times by 9.6 squared. So we've got our answer to be 3,456 joules. Now all that kinetic energy will dissipate, will go to another energy store when the person is slowed to a standstill. So we can say the work done in this situation, the energy transferred, is going to be this kinetic energy. Now you've also got to recognize that there's another equation, which is that work done is equal to force times by distance. Now you tend to find that if it's a 6-mark question, you'll have multiple equations you'll need to use. So we can therefore say 3,456 is equal to force times by the distance, which is 25. You rearrange that, you make force the subject, you work it through to be 138.24 newtons, but the question wanted the answer to two significant figures. So you have to round 138.24 to 140 newtons. Again, 1 and 4 are your two significant figures, then 0 is the placeholder because there's 3 digits before you get to your decimal point. Right, we're now going to look at a few topics from waves which will come up on the 2022 examinations. So the first question says a car is fitted with an ultrasound sensor. The sensor emits and detects ultrasound. The sensor warns the driver if the car is too close to another object. Explain why humans cannot hear the ultrasound emitted by the sensor. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important you understand the definition of ultrasound, and that ultrasound has a frequency above 20,000 hertz. Now why is that important? It's because that's above human hearing, because human hearing is a range from 20 hertz to 20,000 hertz. The definition of ultrasound, it is a sound with a frequency above human hearing. The next question says, if you look on here, the sensor emits an ultrasound wave. The wave reflects off the wall and is detected by the sensor. The sensor measures the time taken between the wave and being emitted and detected. The speed of the ultrasound in air is 330 meters per second. The reflected ultrasound is detected 0.012 seconds after it's emitted. Calculate the total distance travelled by the ultrasound wave, and then finally determine the distance between the sensor and the wall. So pause the video now, then unpause the video when you want to go through your answer. Right, so what you're going to do is use your equation distance is equal to speed times by time. Now what's our speed? It's 330. And what's our time? Well, it's given in seconds, so it's 0.012 seconds. So you get 3.96 meters. Again, substitute the values into your equation, firstly to get the first mark, and then secondly, write out the answer fully to get your full marks. Now what's the distance between the sensor and the wall? Now you've always got to remember that with ultrasound, it's measuring the distance there and back. It's gone from the car to the wall and back to the car. So what you do, the difference between just the sensor and the car, you're going to be half in that distance, so it's going to be 1.98 meters. The next question says, when the car gets too close to an object, the beeper gives a warning to the driver. The beeper emits sound waves that travel at a speed of 330 meters per second and have a wavelength of 0.75 meters. Calculate the frequency of the sound wave. So pause the video now, then unpause the video when you want to go through your answer. Right, you've got to be able to use the wave speed equation, which is given to you in this particular exam, and that is speed is equal to frequency times by wavelength. Now look again at how the marking gives you your marks. You've got to substitute the values from the question into the equation. So 330 equals f times by 0.75. You rearrange it to make frequency the subject for your second mark, and the third mark is writing out your answer, 440 hertz. The next question says, a student investigated how the angle of refraction varies with the angle of incidence for light entering a rectangular glass block. So plan an investigation to obtain the results in table 1, and you should be including a diagram in your answer. So pause the video now, then unpause the video when you want to go through your answer. Right, in an experiment style question, again, what you want to talk about? You want to talk about what the experiment actually is, what you're measuring it, and what device you're measuring it with, and then what values you're going to do this for, and then how you're going to get accurate results. So the first thing is talk about what the experiment actually involves you doing. So you draw around to the glass block, then you talk about what you're going to use as your measuring device. Use a protractor to measure an angle of 90 degrees to the glass block. Draw your normal at 90 degrees to the block. Remember, you should always draw normal to any optical experiment. You measure an angle, firstly probably 15 degrees, using a protractor. So again, talk about measuring your angle of incidence, talk about the measuring device, talk about the good practice. So you measure the angle from the normal and mark the position of the incident ray. Then use the ray box to produce a narrow ray of light. Shine the ray of light along the position of the incident ray. Then draw crosses along the ray that emerge from the block, and then draw in the path of the ray through the block by drawing a straight line between the incident ray and the emergent ray. Then measure the angle of refraction to the normal using a protractor. Then repeat for different angles of incidence. And again, try and draw a diagram to explain this. But again, for every experiment, talk about what the practical actually involves you doing, a step-by-step guide. Talk about what things you're going to measure with what particular measuring devices and what values you're going to do for this, and finally how you're going to get accurate results. The next question says, an X-ray has a frequency of 2.4 times 10 to the 19 Hertz. The speed of X-rays in air is 3 times 10 to the 8 meters per second. Calculate the wavelength of the X-ray. So pause the video now, then unpause the video when you want to go through your answer. So like mentioned before, you've got to use the wave speed equation, which is given to you on your equation sheet for this 2022 examination. So you write out all the values. So you'd say speed is equal to frequency times by wavelength. So it's 3 times 10 to the 8 equals 2.4 times 10 to the 19 times by wavelength. You then make wavelength the subject by doing the following. You then work out your answer to get your third mark, 1.25 times 10 to the minus 11 meters. The next question says, a student investigated this particular experiment. Okay, how can we get this result? So it's the same questions before, but let's just review how you get this through again. So like we talked about before, it's draw on the idea or on the line to place the mirror on, draw a normal at 90 degrees, measure the angle of incidence using a protractor, angles measured to the normal, draw your incident ray in, shine a ray of light along the incident ray, draw crosses along the reflected ray, draw in the reflected ray, measure the angle of reflection, repeat for different angles of incidence. Now again, so this one was reflection and the previous one was refraction, but it's the same idea that we followed previously. So if you look at the mark scheme, how do you get your marks? You talk about what the practical is going to be, you're going to talk about what values you're going to measure, you're going to talk about what measuring devices you're going to use for this, the protractor, you're going to talk about what actual values you're going to use for this, and then going to talk about how you're going to get accurate results. The next question says the following: the angle of reflection should be equal to the angle of incidence. Suggest two sources of error in the results, and then the student looked at herself in the mirror and gives two properties of the image in the mirror. So pause the video now, then unpause the video when you want to go through your answer. Right, so why can you get an error in the reflection experiment? That's what the question is asking you. So the obvious one could be you misread the protractor, or you could say the mirror wasn't vertically set up, that the ray of light was too thick, that the pencil that you used to draw your lines in was too thick, or that the mirror was not perpendicular to the normal, or that the mirror was not thick enough or was in fact too thick. It's very important that you've got to write specific errors to that practical, not just general things like human error or parallax error or random error. You've got to give actual errors when it talks about actual experiments. Now the second thing is talking about properties of images formed in mirrors, and you should just know these are factual things you've just got to remember, that in a mirror you get virtual images which are upright, which are the same size, and they're laterally inverted. That means left and right is switched round. Now again, what does virtual mean? A virtual image is an image which cannot be projected onto a screen. It's where the rays don't actually cross, they're just being projected that they would cross. The next question says, a student shone a ray of light onto a glass block. Figure 6 shows a ray of light instant on the glass block. Complete figure 6 to show the path of the ray of light through the block and then after it leaves the block. So pause the video now, then unpause the video when you want to go through your answer. Right, it's very important that you can draw refraction in many situations. Now you've got to note that what happens is that when light goes into a denser medium, and it is a denser medium because it's air and it's into a glass block, it tells you this in the question and it labels it for you, so it's very clear about this, that the ray of light will slow down. Now, if the ray of light is slowing down, it's going to move towards the normal. Now, the next thing to note is that you've done the first bit when it's gone into the glass block, but you're then going to do out of the glass block as well. So when it leaves the glass block, it's going to be speeding up because it's back in air. It's back into the less dense medium, so it's going to speed up. So therefore, it's going to move away from the normal. And actually, it's going to be the same speed as when it entered, because it was entered in before it was in air. So afterwards, it leaves, it's going to be back in air. So that in fact, the line should be parallel. The next question says, Table 4 shows the range of wavelengths for 3 types of ultraviolet radiation: UVC, UVB, UVA. UV lamps emit one type of ultraviolet radiation. The ultraviolet light emitted by the lamp has a frequency of 1.2 times 10 to 15 Hz, and the wave speed is 3 times 10 to the 8 meters per second. Calculate the wavelength of this ultraviolet wave, and then what type of ultraviolet light is emitted by the lamp. So pause the video now, then unpause the video when you want to go through your answer. Well, for the first one, once again, we've got to use the wave speed equation, which is given to you on your equation sheet. So again, for the first mark, you just directly substitute the numbers into this equation. So we say 3 times 10 to the 8 equals 1.2 times 10 to 15 times by lambda. You then make lambda, which is wavelength, the subject, and we work out to be 2.5 times 10 to the minus 7 meters. Now, this next question is asking you to look at the table above you, which you're going to have to work out what values are in nanometers. Now, nanometer means by times 10 to the minus 9. So therefore 2.5 times 10 to the minus 7 is about 250 nanometers, or 250 or 2.5 times 10 to the minus 9. So we look on the table, which one is that? And that's UVC. The next topic we're going to look at is space. So all these topics are topics which will be coming up in the 2022 examination paper. So the first question is, the ISS travels at a constant speed around the Earth. Explain how an object can be accelerating whilst travelling at a constant speed. So pause the video now, then unpause the video when you want to go through your answer. Right, this links into actually the forces topic as well, and it's the idea that acceleration is the rate of change of velocity. Now, velocity is a vector, so that means that you can either change the magnitude or you can change the direction to actually change your velocity. So whilst it's traveling at a constant speed, the direction as it moves around in a circle is constantly changing, so therefore the velocity is changing, so you've got an acceleration. The next question says that rockets do work on the ISS. Explain the effect that work done has on the orbit of the ISS, the International Space Station. So pause the video now, then unpause the video when you want to go through your answer. Right, so if work is being done, the important thing to note is that energy is being put into the orbiting body. So if energy is being put into the orbiting body, we can say that the kinetic energy is going up, because that's where the energy is going. So therefore, the object will increase in velocity. Now, it's important to note that the higher the velocity, you need an increase in orbital height again. Why is that? Because work is being done into it, so therefore also it'll be further away from the object because it's being pushed away from the planet. So the orbital height will also increase. The next question says, the Sun is in the main sequence stage of its life cycle. Explain why the Sun will eventually leave the main sequence stage. Then describe the stage of the life cycle of the Sun from leaving the main sequence until it stops emitting visible light. So pause the video now, then unpause the video when you want to go through your answer. Right, so you've got to understand what the main sequence stage is. So the main sequence stage of a star is when hydrogen is fused into helium. So when will it leave the main sequence stage? It's when it will run out of hydrogen. So, because at that point the forces within it will become unbalanced when it then starts to carry out helium fusion. So that's when it'll leave the main sequence stage. Now describe the stages of the life cycle from leaving the main sequence stage. This is a fact you've just got to learn. So when you leave the main sequence stage, the star expands and cools to form a red giant. It then sheds its outer layers. It then becomes a white dwarf and cools until it eventually forms a black dwarf when it'll stop emitting radiation or light. Now importantly, in this question, if you look at it, it says describe the stages of the life cycle, not explain. So you don't need to explain why it becomes a red giant. You don't need to explain why it becomes a white dwarf or a black dwarf, just to describe those processes. So just be very careful when you're answering these types of questions. The next question says, the properties of a star depend on the mass of the star. A star with a much greater mass than the Sun leaves the main sequence. Explain how the star will change during its life cycle, and you may wish to include a diagram to your answer. So pause the video now, then unpause the video when you want to go through your answer. Now, you'll notice in this question, it's talking about explaining the answer. So you've got to actually explain what's going on. Now, you've got to be able to describe and explain what's going on for a smaller star and for a larger star as well. So you would say that it expands and it cools to form a red supergiant. Now, at this point, the helium nuclei will fuse to form carbon, and then fusion will produce the heavier nuclei. Then eventually, when it gets up to about iron, the core will collapse and the outer layers will explode in a supernova. At this point, every element larger than iron will form, okay, in that supernova moment. And as the supernova pushes the elements in throughout the universe, they'll spread out. You'll have a nebulae of all these different gases, all these elements, and then depending on the mass, you'll either be left behind with a neutron star, or if it's extremely massive, you'll be left with a black hole. Now again, remember to always say that it's a neutron star or a black hole. It's not both of them, it's either or. Now you're going to have to link the stage of the life cycle to the fusion process. So it's important you mention in the main sequence, it's hydrogen fusion. In a red giant, it's helium fusion, all the way up to iron fusion for a larger star, carbon fusion for a smaller star, and then after in the supernova, you actually produce every element above iron. Now again, it's very important you remember those key ideas. So hopefully you've enjoyed this particular revision session. If you've been successful and you've learned in this revision session, you should be able to answer GCSE Physics examination style questions. You should be able to assess your own understanding on GCSE Physics and understand what topics you need to improve upon for GCSE Physics. So I hope you've enjoyed this revision session on the paper 2 topics of GCSE Separate Science Physics, focusing on the topics which will come up on the 2022 examination paper. Thank you very much for watching and have a lovely day.